Hello Year 11 students, and now we're going to do some more differentiating, but this time the powers will be fractions. So let's see how we get into it. First one we're going to do, one part A, is differentiate y equals the square root of x. Well, we can't differentiate x when it's on the bottom of a fraction or if it's in surd form. If it's in surd form, we need to change it from surd form to index form. Now remember, there's a 2 sitting there on the seat. There's a 1 there. So remember, the square root means to the power of, on the bottom is the 2, so it's 1 over 2. X to the power of a half is a fancy way of writing square root x. Now I can differentiate it if it's written in indices form or index form. The derivative is equal to, take the half and times it to the 1 out the front. Half times 1 is a half. Take the power and decrease it by 1. Half take away 1 is minus a half, which equals 1 over 2 x to the power of a half. Notice what I did. X to the power of minus a half is on the top, but I've moved it to the bottom, so it changes to an x to the power of a half. And then that can become 1 over 2 square root x, because x to the power of a half means square root x, and we're finished. Part B. Can't differentiate that because there's surd sign as well as the x's on the bottom of the fraction. So we know the square root of x means x to the power of a half. So this question is actually y equals 3 x to the power of negative a half, because the square root came from the bottom. I can now differentiate. Can't differentiate till you set it up in index form. Take the power, minus a half times 3 is minus 3 over 2. X to the power of minus a half minus 1 is minus 1 and a half, which we're going to write as minus 3 over 2. Let's tidy this up a bit. There's our minus 3 over 2. I have x to the power of minus 3 on 2. I'm going to move that to the bottom of the fraction. It'll become x to the power of plus 3 over 2. And if I put that back into surd form, because it was originally written in surd form in the question, that becomes x. Now sitting on the seat is a 2. I don't really need to write the 2. And there's a cubed. And there's my final answer. Let's try part C. I can't differentiate this yet because I've got a surd part there. So I need to think of this as x to the power of 5 times x to the power of a half. The square root of x means x to the power of a half. And if you look at that, it becomes, well, you're multiplying with indices, so you've got to plus the powers together. 5 plus a half is 5 and a half, so it becomes x to the power of 5 and a half, which we write as, in improper fraction form, 11 over 2. It's standard practice to write the powers in improper fraction form. I'm ready to differentiate this now. 11 over 2 times the 1 out the front gives 11 over 2. 11 over 2 take away 1. 11 over 2 take away 1 gives 9 over 2, which means my answer is 11 x to the power of 9 over 2. I don't move that to the bottom because it's already a positive power, but I could put it back into its surd form. And remember, when you look at the fraction 9 over 2, 2 is on the seat, so I could put a 2 there, and then it's to the power of 9 because that's on the top. That's your final answer. Bit messy, but that's the way it is. Let's go to part D. Oh, this question's a bit more challenging because I've got an x and a square root x, so it becomes minus 2 over x to the power of 1, that's the x, times x to the power of a half, that's the square root x. So it becomes minus 2 over 1 plus a half is 1 and a half, x to the power of 1 and a half, which is x to the power of 3 over 2. Now I've moved that up the top. So if I move it up the top, 3 over 2 becomes a minus 3 over 2. The power changes. Now it's ready to differentiate. If I differentiate, minus 3 on 2 times minus 2 gives plus 3. X to the power of minus 3 on 2, take away 1 gives minus 5 on 2, which could be written as 3 over x to the power of 5 on 2, which could be written as 3 over the square root of x to the power of 5. And there's your over 2 there that you don't need to put. Your final answer for that. Let's go to part E. Again, we've got a square root, so we need to rewrite this question. So that becomes y equals 9 take x squared, all in brackets, to the power of a half, because to the power of a half means square root. But because I've got a bracket with a power, I need to use the chain rule. So the derivative equals, the half multiplies to the number in front of the bracket, which means a half times 1 is a half. Differentiate the inside of the bracket. So 9 take x squared. The derivative of 9 drops out, minus x squared. The derivative of that is minus 2x. Rewrite the bracket. Take 1 off the power. A half take 1 as minus a half. Now, tidying this bit up, a half times 2, a half of 2 is 1. So a half of minus 2 is minus 1. So you get minus x over 9 take x squared to the power of plus a half. I'm sending the bracket, because it's got a negative power, down to the bottom. Now, I could have not even written that line altogether. I could have just gone straight to this, because I know to the power of a half means square root. And there's your answer. Part F, we can't differentiate because of the surd, as well as the fact that it's on the bottom of a fraction. Now remember, square root means to the power of a half. So this question could be 2 plus 3x squared, all to the power of minus a half, because it is to the power of a half, and I move it up the top. I don't need to put the 1 out the front of the bracket. Let's use the chain rule. The power, minus a half, times this to the 1 out the front, minus a half. The derivative of the bracket, well, the derivative of 2 drops out. The derivative of 3x squared is 6x. So it's at minus a half times the derivative of the bracket, times the bracket doesn't change, but the power goes down by 1. Negative a half take 1 is negative 1.5, or negative 3 over 2. Now when I look at this, a half of 6 is 3. So minus a half times 6 is minus 3. I get minus 3x over 2 plus 3x squared to the power of 3 over 2, because that was a negative power and I moved it to the bottom of the fraction. It becomes a positive power. Let's tidy it back up into its correct form. It becomes minus 3x over the square root of 2 plus 3x squared, all in brackets, cubed. That cubed comes from the little 3 there, and there's a 2 that I don't have to write out the front there. And that's the final answer to that one. You can see they do get messy and challenging, but with practice they become manageable. Let's try part G. With this one, we're going to notice there's an x on the bottom, so we'll go y equals, now if that x on the bottom is an x to the power of 1, so I'm going to move it up to the top and make it an x to the power of minus 1, and it's going to multiply to everything that was there. So when I multiply this out, x to the minus 1 gets multiplied to each of the 3 terms. So x to the negative 1 times 2x squared, you add the powers, you get 2x. The next line, minus 5x x to the 1 and x to the minus 1 give x to the nothing, they just drop out, plus 4x to the minus 1. So the derivative equals 2 minus 4x to the minus 2. Derivative of 2x is 2. The derivative of negative 5, nothing. Derivative of 4x to the minus 1, minus 1 times 4, minus 4x to the minus 2. And I'll just return that to a tidier form. And we can leave it like that. You could group it together, but that's fine. H, using the same technique, H, we're going to write y equals, now we know the bottom of the fraction is the square root of x, and we know the square root of x is x to the power of a half. So I'm going to write it as x to the power of minus a half, and it's going to multiply to everything on the top. So when I multiply it to everything on the top, the powers of x have to be added. So I get 8. Now minus 1 added to 1 becomes x to the power of a half. Minus 4x to the power of minus a half. It's now ready to differentiate. So let's differentiate. Take the power, times it out the front. Half times 8 is 4. The new power is 1 less. So half take 1 is minus a half. For the second part, minus a half times minus 4 is plus a half of 4 is 2. So plus 2. Negative a half take away 1 is negative 1.5, or negative 3 over 2. Let's put it back into the form that it was written in. It becomes 4 over x to the power of a half, which I know is square root x, plus 2 over x to the power of 3 over 2, which I know is square root of x cubed. And there is your answer. So they're quite challenging, but with practice, they'll become manageable. Enjoy yet another mathematical experience in the world of differentiation. Bye for now.